Hey, what's up guys? My name is Cherno and welcome to episode 2 of season 2 of game programming. So last time we basically just took an introductory kind of planning session as to what we would do in this season and specifically what we would do multiplayer wise. So we're up to the point of bringing Rain, our game, to be a multiplayer game. And so we have a lot of things that we need to set up for that and obviously write all of the networking code. And we kind of just went over the plan. So if you guys haven't seen the previous episode, you're going to want to watch that first. It'll be a annotation on my face or something, or I just realized my face doesn't take up the whole screen. There'll be an annotation on the screen somewhere to go back and watch the previous episode. So do that if you haven't, or if you just want a refresher as well. Basically, what we're going to do now is put that plan into action by beginning to write all of our code. So last time I wrote this little to-do here that says connect to server here. And I kind of went over the order and the order of this is going to be pretty important as well, because what will happen is, I mean, I remember right now, like this was like last season, but we added this whole net player thing, and that would kind of be like, if we launch this thing right now, I think the net player was, yeah, like this little thing. We basically just experimented with having an entity here, which is a mob. Yeah, whatever, Google Drive. We had this entity here, which is a mob. I mean, I'm not even sure what we really did with this. We were setting X to a certain position, but the point is we managed to make a mob that was kind of in this net section of our code base, which is going to be important as well because we're going to receive information from the server as to which net players to add and all of that stuff. So it's going to be pretty exciting once we get all that up and running. So to begin doing that, the first thing I've decided I want to do is actually set up the server. So we're going to make a new project for this. So right over here in our navigator or in your package explorer, however you roll, if you just right click and hit new, you can select Java project. And I'm going to type in rain server. Okay, and that's going to be our server. This is going to be a completely standalone application. As I covered last week in the planning session, we are going to have a standalone server. So we have like a client server kind of setup, right? Where we have a single server and then multiple clients connect to that server. And the only way the clients communicate to each other is through that server, right? There's not going to be any kind of peer-to-peer stuff. It's just going to be client to server. And so of course we need a server for that to work. So I'm just going to look at our current namespace. So we have com the Cherno rain, and then we have sure. Okay, so I guess what I'll set up here, or what package I'm going to put all this in, is going to be com.thecherno.rain server. I could do rain.server, and I guess that way it would kind of be the thing, but that's just too many. Like this is clearly going to be the server. So I'm happy to just leave it like that so we don't have too many folders here. Okay, cool. And so what we'll do is we'll just call this, I guess, main. I'm actually going to call it rain server. The reason is that it'll just make it a little bit easier to, because we've already got main for here. It might be, actually we've got game here. Yeah, but still, I'll call it rain server. So this is going to be the main class. I'm going to just make sure I tick this here so that it automatically generates my main method. And that's it. We've created a brand new Java application that is specifically going to be our server. Now this has nothing to do with this. That's one thing I want to quickly mention as well. We will be referencing one project with this, but it won't be Rain. It'll be the Rain Cloud serialization project, right? Because we want to be able to use that serialization stuff that we wrote inside this Rain server project. But we are not going to link Rain server and Rain together at all. They don't go together at all. They're completely standalone things. As far as they know, like they don't share any code at all, okay? They're completely different things. The only thing that the Rain server is responsible for doing is basically receiving data, transforming it somehow, and then sending it back, right? That's what happens. It's as simple as that. It receives data over a network, it does something to it, or it might create new data based on that data it receives, right? And then it sends it back into the network, and that's it. So the way that I like to develop these things, honestly, is just really kind of try and oversimplify things. I don't want to say oversimplify because what we're doing here isn't really simple, right? But it also is in a sense, right? When you boil down any kind of software engineering problem, right? It does actually become quite simple. You just have to really think about it and break it down into small enough chunks. And really the problem that you're solving should never be excessively difficult. Now I'm talking about most things that you guys will probably end up doing, right? I mean, obviously there are problems out there that are really difficult to solve. But this isn't one of them, okay? In terms of a high level approach, it's a really simple problem that we're trying to solve. We're simply trying to accept data, read it, process it, generate new data, send it back to that thing that sent us the initial data, okay? That's all we're doing. So that's my personal approach to these kind of problems. I like to think through them, right? And just make sure that I'm not overthinking it, right? Do not overcomplicate things. That's the worst thing you can do in software engineering, in my opinion, is to overcomplicate things, because that's when you start deferring writing the actual code, like I am right now. No, but seriously, that's when you start kind of delaying and deferring the writing of code, and you start having, you know, more and more time to think about the design, and you start procrastinating essentially, okay? So overcomplication is terrible. Oversimplification, in fact, is better, I would argue. But the point is, that's what we're trying to do here. So that's how we're gonna start off. We're not gonna start off writing this incredible netcode here. We're just gonna get these two projects communicating, Rain and Rain Server, over the network. Okay, if we can do that, if I can set up a laptop over here right next to me, and I can connect to this, and I can see the information that's being transmitted between those two, that's a success. So that's going to be our first goal, right? Just the transmission and I guess the sending and the receiving of data from two separate hosts, okay, via a server. So basically just client to server, server to client. That's all I want. Sorry, microphone. Keep hitting this thing. Anyway. That's the idea. That's our step one. Okay. So to do that, we're just going to start off with making a simple class here. I'm actually not even sure what to call this. I might call this server or something. I'm actually really not sure what to call this, because I was going to call it Rain Server, but then I decided to call the main class Rain Server. So I guess I'll just call this server. And it's going to be kind of like our main server class. It's going to contain all of our methods that we're going to need for actual server code. Okay. So the first thing, and also one thing I should note is that this class instance, right, an instance of server literally represents an instance of, you know, the Rain server. So if you make another instance of this class, it's going to be another server. Okay. I mean, the name should imply that as well. That's another thing I want to mention, right? With object-oriented programming and stuff, you really want to make sure that objects actually represent objects, right? You're not just making classes for absolutely everything because you've been taught to do that. That's another thing that I really don't like about object-oriented programming, is when it becomes more about classes than actual code and functionality, right? I mean, as much as you want your code to be beautiful, you also don't want to be just creating classes for absolutely everything, because you have no idea how to solve the problem without that, right? Anyway, one thing I want to mention for this series straight away, actually, because this is still episode 2 of season 2, is I'm probably going to introduce some more kind of software engineering approaches, and I'm going to talk a little bit more about programming guidelines and like stuff like that, right? So if you guys are cool with that, just let me know what you think of that, or if you would prefer, like, because I don't want to just aimlessly write code for you guys. I mean, if you want to like, okay, you could do two things. If you just want to jump to all the codes straight away, you can just support me on Patreon, right? $5 a month gets you access to the GitHub repository, which has all of what I'm going to write in like the next 5 episodes already written, right? But B, you could just look at the thousands of open source projects that have a client server thing written in Java, for example, right? So I mean, I'm not trying to bring something especially new to the table. I'm just trying to go over my thought process when I approach problems like this, and how I'm going to solve it, and why I write the code that I do. Okay, so that's kind of the way that I'm going to lay out this series. So let me know what you think of that. But that's kind of my opinion of, I think that's probably the way I'm going to do it, because it makes sense to me. Okay, so when we start up a server, again, we are starting a new server. So the one thing that we really do need to provide is a port, okay? We don't need an IP address or anything like that. Obviously, our server is the IP address. The IP address of the server is going to be localhost, right? And for anyone else connecting to the server, it's going to be either the server's local or external IP address, right? So that's all fine. We don't need to do anything with that, but we do need a port, okay? Because the port is just going to define which port our application is going to connect to the network through, okay? And our application being the server in this case. So we'll have a private int port. I want to quickly cover this as well. And one thing I want to say as well is that This series is going to be a lot of me talking about stuff, by the way. So just get used to that, or leave. I mean, either way. But I was going to say that the original game programming series was a lot of this as well. Like I was introducing stuff like, hey, what does private do, right? Obviously, I'm not going to do that because the original game programming series was, or like the season 1 rather, was more about teaching you guys like Java as like along the way of making a game. Now I kind of assume that you know what Java, like how Java works, at least syntactically, okay? And what all the keywords do, okay? But I'm not going to, I am going to kind of comment on things that that are general kind of coding practices and also my style, okay? Because a lot of these things, like in terms of coding practices, sure, there are a lot of like, there are a lot of general, like do this, don't do that. There's a lot of that kind of stuff, right? And there are actual concrete cases in which like there is under no circumstance you should do this, right? There do exist like things like that, essentially, rules that you really should follow. But then also there are a lot of things that are just opinions, okay? And I'm just gonna comment on my opinions. So if you don't agree with my style or like the way I write code or the way I do that, that's totally fine. Like this is a, you know, I like to think that this world is kind of free and certainly something as insignificant as programming, you are totally free to write code the way you want, right? I mean, it's, you know, it's your life. You can do what you want. I'm not gonna like force you to do this as if it's like some huge deal. It's not, right? But I'm just going to comment on the way I do things so that if you guys like that, or if you guys don't get why I do things, then you can see, right? And maybe I'll teach you something new that you don't know. That's the goal. So a lot of people ask me why I make things public all the time. Now, in this case, I've made the port private, but sometimes I will make public variables. And again, I get a lot of questions where people say why I've been taught, like they will tell me that they've been taught to make the variable private and then just make a getter and a setter. So you have something called get port and you have something called set port. And then you do that. This gets taught a lot, unfortunately, because I think it's really stupid. I honestly think that this is one of the worst things ever. In fact, this is like one of those things that Java is actually kind of known for some reason. I mean, with like C#, which is kind of the other popular managed programming language out there, you kind of have properties, so it's a little bit different because that's kind of implied. Like, you know, in C#, for example, you'd make a public int called port, and then you'd have like get set or something like that, and that's kind of done, and that's kind of your getter and setter in one, right? And you have that automatically. In Java, you don't have that, so you end up having to create the methods yourself, okay? Whereas C# will kind of hide it behind syntactical sugar, I guess, just to make the syntax look nicer via properties, and then generate these methods in the actual kind of generated code. But the idea is Java doesn't provide that, so you end up doing stuff like this. This is stupid. I don't understand why people do this. I really do not, right? There is no point in doing this whatsoever, right? Get rid of these two methods, make the variable public, you will achieve exactly the same thing, and it'll look nicer, and you won't have extra methods that your CPU will then need to call, right? I mean, hopefully this stuff like this gets inlined, but that's besides the point, right? I'm not gonna talk about optimization here. I'm just talking about, and performance. I'm just gonna talk about just how much that messes up the code base, right? I mean, in a situation like this, it's not the worst thing in the world. Like, it is pretty bad and I would never do it myself. But if you've got like a vector class or something, like a mathematical vector class, and you've got private int xyz for a private float xyz, and then get set for each one of those, then just please stop doing that. Honestly, I don't understand. Like, please stop doing that. It's just, don't do that, okay? I'm actually just gonna say that. Don't do that. It's really stupid and I don't like it, okay? That being said, if you like it, and if that's your style, yay. But just, for the rest of you who are unsure, pick my way because it's the correct way in this case, okay? I'm not always right, but I am in this case. That being said, if I just wanted to make, that brings us back to the first kind of point. And I know this is going to be the longest video about writing one-line code ever, but this is what this series is about, right? It's about learning how to write code, not necessarily just how to make a game. It's actually how to make a game, right? And it's not how to make this game, it's just how to make games, and it's how to program. And that's kind of what this is about. So Sorry, if I seem kind of pissed off today, I'm not really, but I'm just kind of, I really want to have a bit of a clear definition of what we're doing here. Okay, so that's the way that works. But that being said, why did I make it private? Because I'm not going to have a setter, okay? I'm just going to have a getter. So by doing that, I've effectively made the variable read only from outside this class, right? So any class outside of the server class, for example, rain server, where we're going to, you know, instantiate our server. So server equals new server. We'll say port 8192. You guys know from the network chat programming series, that is my favorite port of all time for some reason. When we do something like this, I'm not going to be able to do anything. You can see I'm not exposed to ports, so I can't change the port. And if I do that, of course, that's not going to work because, well, it copies the variable, right? It just returns a copy of what 5 is. It doesn't give me a reference to that port integer. So I definitely can't assign stuff like that to it like I could in C++ if we were returning a reference. Oops. A reference, for example. Okay, so in Java, that's always going to return a copy of the integer. So there's no way I can do that, right? So there's no way for me to actually set port, and that's the way I want it to be, right? When you, or at least for now, when you do something like this, when you create a server, you're not going to be able to change ports because what you would have to do anyway is shut the server down and then create a new server. Okay, so you could have a set port that does that for you, but again, we're just going to say there's no reason to change port, create a server. If you really want to change port, maybe close down the server and then just make a new server, which is on that new port that you wanted, like 8193. Okay. So just a few things to think about. The other thing is, I will note one other use for having a private int and then both a getter and setter. And that is if you're going to do more than just set the variable. If you have exactly this code, then yes, that is bad. Don't do this, right? But if you're doing some other stuff like port ×2, that's totally okay. Now, obviously this is a nonsensical case because you wouldn't be doing this ever. Like, it doesn't make sense to just double the port, right? But you gotta have one of those every episode, by the way, otherwise it's not a game programming episode. Anyway, if you're doing something like that, maybe you're logging extra stuff like port was changed. Maybe you're actually restarting the server. Like I said, you might want to restart the server if this happens. So you'll actually, you know, restart server with new port or something like this. Then yeah, you can have a getter and setter. That makes sense. And again, if I see a getter and setter like that for a variable, I know that it's going to do some extra stuff. But if you just have that, then make the variable public, please. Save us all some time. Okay. So we have a port. We're going to have a void called a public void. I'm not even sure if this should really necessarily be public, but we will definitely have. I'm actually probably going to make these things private. So we'll have a private void listen, right? We're going to have a private void probably process, okay? And then a private void or a public void called send, okay? And the general consensus here is we're going to send some data. Process as well is probably going to process a packet, okay? The packets that we're going to use as UDP packets, so that will be in Java, it's called a datagram packet, okay? Listen is generally going to be on a separate thread, which specifically listens for things. So basically we're going to have a listen thread, which when we start the server, which we will do in a separate thing. So that's another thing that I generally, with things like servers, right? I don't like to just implicitly have it so that when you create a new server like this, it automatically starts it, right? I like to kind of separate my creation and like setting up all the data, which is what this is doing, right? Essentially, we'll do some kind of initialization stuff. And then when I'm ready to, that's when I actually want to start the server. Okay, so we do our we begin listening on that specific port, you know, in the start method. That way you're not tied to having to create your server when you want to start it. You can do other stuff here, right? And then eventually call server.start when you're ready. Okay, that's very important to do in my opinion. So let's just save that. But that's very important to do, right? As in, I like doing that because it lets me do other stuff. And you might have, you know, set other properties. You might have other stuff that you want to set that you don't pass through the constructor that you can now do because the server hasn't started yet. okay? Whereas you would be basically tied to providing everything through the constructor as parameters if you didn't do that, okay? So again, just a nice little thing that I like doing. So the listen thread is going to be a new thread. Now we're going to use the listen method as what the thread is going to run, right? So this listen method is going to be on this new thread. And so the way that I'm going to do that, in the past, you would have had to, in Java like 7 and below, I think, you would have had to create a new runnable anonymous inner type. Either that or create a completely new class yourself. But, and like usually you would do this, right? You create an anonymous inner class with the run method, which would call listen, and then you essentially get that, right? And then of course you'd have to start the thread. Now in Java 8, so listen thread.start, and there you go. We've called this function now on this listen thread, on this new thread. Now, in Java 8, however, we're introduced to lambdas, which other languages have had forever. So a lambda is basically just a way to take this anonymous inner class and compress it down into basically one line, right? And basically what a lambda is usually is kind of like, it's essentially a function that you're passing in, okay? You're saying here's an anonymous function rather than anonymous class, which is what this is, right? And then that function can do something specific. So it's just a way to pass around functions as actual kind of function pointers, essentially, is what a lambda is. It's just a function. So the way that would look like syntactically is a little bit weird, and every language does it differently. Java does it with a weird little arrow, as I'll show you in a minute. But basically we have, first of all, the parameters that we take into this new function. So if listen had any parameters, we would put them there. Or rather not really, because this isn't really a lambda that we're creating for listen. It's actually a lambda that we're creating for the run method that's inside runnable. So in that case, that run method doesn't have parameters, so we don't need to worry about that. But if the run method did have parameters, we would be putting them in there. We have this weird arrow, and then we can write as much code as we want inside 2 curly brackets, right? So, and then basically this turns into the body of that run method that we had, okay? So it becomes really simple, and I'll show you the difference in a minute here. But basically we can now call the listen function. Now I think we can also do that without these brackets if it's just one line. Oh, maybe not actually. Can we? Yeah, there we go, right. Okay, so we can, if it's just one line of code with like no semicolons or whatever, we don't have to use the curly brackets to enclose it. We can just do something like that, okay? And that is functionally equivalent to what we did before. It does exactly the same thing. It still creates that inner class, right? It still does that. In fact, I'm not sure if we can see here, but you may be able to see that inside the compiled stuff. I'm not sure how that exactly works though. Maybe not. Can I browse to that specific thing? Yeah. Okay, doesn't matter. You'll have to trust me. That still does the same thing. It's just that it looks different. So again, what it looked like before was new runnable, blah, blah, blah. And then we had the listen being called here. So what we've done basically is we've taken out this new runnable part because we don't need that at all. We know it's a runnable, right? We've taken out public void and run, and we're left with the parameters of run and then whatever we want it to do. Okay, there you go. That's how that works. Very simple, and it will basically call this on our other thread. Okay, now the way that this is going to work, this listening thing, is we're basically going to have a boolean called listening. We'll probably end up making this volatile or something like that. And I'll cover like concurrency specific Java keywords in a completely separate episode. But ultimately, we can use keywords such as volatile to just make sure that the compiler doesn't optimize out certain things that would affect our code. Because when we start changing variables, changing specific memory addresses, essentially from 2 different threads, we can run into problems, okay? Because for example, if those 2 variables are both in the CPU cache and in different locations, and we write to one of them, then that cached variable is not the same as the other cached variable, right? And again, the reason that happens sometimes is if we're running concurrently, we might be on separate CPU cores, and separate CPU cores have their own like L1 cache essentially. So you can run into a variety of problems when you go into like concurrency and stuff like that, and you might have to use fancy keywords like volatile, but We'll cover that as we need to, and I'll try and actually provide specific examples where like not using volatile will specifically not work. Okay, so that you guys can kind of see how that actually works, because a lot of people just write it for no reason, because they think that, oh, okay, I'm going to be using listening on this one thread, so I better make it volatile. Okay, that's, for example, an incorrect use. But anyway, now that we've got that, essentially this is going to be a while kind of listening loop, and we're going to do a bunch of stuff in here. Okay, so the reason we have a thread, first of all, I know that's going to be a question. Why do we make a separate thread for this? Why not just run listen from in here without having to start a thread, right? Why did we do this? Why didn't we just, you know, not have that and just call this? Okay. The reason is that, as you can see, there will be a while, essentially a while true loop, right? When we start the server, we're going to set listening to true. Okay, and we're going to basically start the thread. It doesn't matter what order we do this in, by the way. If we did that as well, that would work. But if we did something like this, oh, actually, it might not. We definitely should set that to true. Otherwise, we might skip past this entire loop and terminate the thread. But anyway, the idea is that this is essentially a while true loop. Okay, a while true loop will block the rest. Like a while true loop blocks our current thread. Right? It's going to be in here until the while true loop is broken out of, or for eternity. Okay? So we obviously want to keep doing other things, not just listening, right? We still want to be able to process packets, which will actually happen from here, but more specifically, we still want to be able to like send data and do all that stuff, whilst also listening. Okay? So to be able to do things at the same time, via having kind of things that block us, like a while listening loop or a while true loop, we need to use multiple threads. Another reason is that when we actually do receive packets, the way that packets are received is essentially by kind of a polling system. What I mean by that is that we'll call something like, you know, we'll have like a socket and we'll call something like a receive. And what that will do, what that function will actually do is block until it receives something. Okay? And we'll cover like terms like blocking and stuff if you don't understand that. We'll definitely get into that when we get some code to actually run. But this will block, right? Which means that if we had that on the main thread, again, until a packet is received, we don't do anything, right? Whereas that's not what we want to do. Even if we're not receiving anything, we still want to be able to send stuff and do other processing kind of tasks, right? So we totally need to have a separate thread for stuff like that. And we'll talk about thread design when we get to more advanced and more specific examples, right? For example, having a thread per client might be a bit excessive. We might have pools of clients which are handled by multiple threads. And again, there are just so many things that we could do. But that is the basics of that. So we have a server which we can start, we can listen, we can process. So when we do receive packets in this listening thing, we'll call the process function with them. So this will kind of run inside here. I've just split it up into a separate function to make it a bit more organized, a bit neater. And then of course we have the send method, which we can call from outside this as well whenever we want to send data. Now right now this has no address, so we have no idea where we're actually going to send it to. So we will probably have to specify some kind of address. But ultimately, that's kind of how that cookie crumbles. So if you guys enjoyed this episode, please hit the like button. If you want to receive the code from this episode and all that stuff, then you can just hop on to patreon.com/thecherno. There'll be a link in the description below. If you pledge at least $5 per month, you get access to all of that through a private GitHub repository, as well as like a commit by commit basis. So you get everything. But that's something you can do if you want to support me and you want to make sure that these episodes keep coming out on time, then highly recommend you do that. If not, then just hit the like button on the video. That supports me as well, of course. Shows me that you guys are interested. And I'll see you guys next week with episode 3. Goodbye. Vroom.